channel. In this video I'm going to show you some examples. So guys, let us start with excuse me, the first example. We want to find the 6 trig functions for a given point. So guys, I'm going to start with part A, and then I'm also going to show you part B in the same example in the same video. So let us start with part A, where the point given to us is -12 and x. Guys, keep in mind this is my x and this is my y. So based on this given information, we have to write 6 trig functions. Guys, we'll start by writing the first 3, and then their reciprocals are going to be the other 3. Okay, so the first thing that we have to do here is we're going to try to create a visual. Okay, once we create a visual, then it's going to become much easier for us to write the sine, cosine, and the other trig functions. Guys, we are going to draw x and y coordinate plane, and in this coordinate plane we are going to identify our point -12 and 5, and x is negative, y is positive. We know it's going to be x negative is on this side and y positive is all over above x-axis, so it is going to be somewhere in the second quadrant. Guys, we are not really interested in exactly identifying it where it exactly lies in the second quadrant. All we care for right now is that this is in the second quadrant, so let us plot that point in the second quadrant. So for example, this is right here, -12 and 5. Let's say it is right somewhere right here. And if I join this point to the origin, guys, this we can think of this as a terminal side, and then we always measure angles with this as our reference side. And guys, we are going to, most of the times we're going to measure angles in a counterclockwise direction. So the angle is going to be measured like this, and let us call that angle as angle alpha. Guys, you're free to use any other Greek symbol or any other letter to denote that angle. I'm going to use alpha here. And then what else I'm going to do here, guys, this is my -12 and 5. Let us call this point P. You can call it whatever you like. So if I drop a perpendicular here, then we're looking at a right triangle, right triangle. And then keep in mind, this is, you can think of this as the hypotenuse of this triangle, or you can also think of this as the radius. And this is my x axis, this is my y. And guys, keep in mind, x is -12 and then y is positive 5. Keep that in mind before we start actually evaluating or finding the 6 trig functions. So guys, before we start evaluating the trig functions, the first thing we should do is we should figure out the length of the radius, or you can also think of the length of the hypotenuse. So guys, to find that r, you got to do r square is the square root of, or you can first start by writing the x square plus y square. Guys, we are also kind of using the distance formula here, but since we're measuring this distance of this point from the origin, it is like x -0 and y -0, so you can just simply write x square plus y square, or you can also think of this as a right triangle, and this is the hypotenuse, and we're just basically using the Pythagorean theorem. So based on this, we can have r square equals to x square is -12 square. Be careful with the signs, you got to put the signs as they are, and then 5 square. And guys, once we simplify, it becomes 169, and when we take the square root on both sides, you get r equals to 13. So r is 13. We have all the 3 quantities that we need in order to write the trig functions. So guys, let us start by writing the first one, the sine of alpha. We know sine is the opposite over hypotenuse, but when we think in terms of coordinates x, y, and r, guys, we know it is y over r. And guys, if we do not remember, it's not a big deal. We can see that this is the opposite. Basically, if we think of this as a triangle, so then this is the opposite, and this is the adjacent, and this is the hypotenuse. But we should like to think in terms of y and r. So y over r, what is my y? Y is 5, and r, we just evaluated r, which was 13. So that is the first one. If I have the sine, guys, we can quickly evaluate the reciprocal of the sine, which is the cosecant of alpha, and cosecant of alpha would be 13 over 5, just the reciprocal of this. Okay, then the second one is the cosine of alpha. We know cosine is x over r. Be careful, x here is negative, right? -12. So it is -12 over 13. That is my cosine. And if I have to write the reciprocal, and we should write the reciprocal of the cosine right away, which is going to be -13 over 12. We just reciprocated it. And guys, keep in mind, we always want to put the negative sign either with the numerator, or sometimes people put it in between, but you would never see the final answer with a negative sign in the denominator. Okay, so either you put it with the numerator or you put it somewhere in the middle. Okay, then the third one is the tangent. The tangent is going to be y over x, right, or opposite over adjacent, and y is 5 and the adjacent, or x, is -12. We got to write it in a proper way, -5 over 12. This is the tangent, and we can also write the cotangent. So guys, the cotangent of alpha will be -12 over 5, which is the reciprocal of the tangent. So guys, that is how we are going to figure out the 6 trig functions given given a point. Guys, sometimes you will be given a point, sometimes you will be given a figure like this. So either way you can figure out the missing pieces and then you can write these trig functions. So this was part A, guys. I'm also going to show you one more example in this video and then we will go into some different types. So let me get rid of this and we can do part B as well. So I mean, it's going to be same steps, but guys, I'm going to show you something slightly different so that you get to see different types of examples. So what is my example 2 in this part B? I have a point -2 radical 3 and -4. So it is slightly different than my previous example. The first thing again we have to do is we have to create a visual. Guys, let us go ahead and create the visual. Keep in mind this is my x coordinate and this is my y point. So if I draw the x and y axis, clearly we can see that since x and y are both negative, that means it is going to be in the third quadrant. So somewhere in the third quadrant, let us say it is right there. And then let me join this. So guys, let us say this is my terminal side and then measuring this angle always with respect to this as the reference side, and let us call this angle, in this case let us call this angle as theta, very standard way of expressing angles. And then guys, keep in mind we can draw this, make a right triangle here if you like, and then identify our x and y. So -2 radical 3 is x and -4 is y. So this is my x, -2 radical 3, and then the corresponding y is -4. They are both on the left side and y below x-axis is negative. Okay, guys, keep in mind these are not actual lengths, these are the coordinates, but we kind of use them as lengths, but these are basically coordinates. Based on these two pieces, guys, we already know now the next step is to figure out the hypotenuse, or if you like to think in terms of the radius. So first thing we have to figure that out. Again, the same thing, we got to write r square is -4 square plus -2 radical 3 square. So you got to simplify that. Guys, there's a radical here, so if you are using a calculator, be careful, put everything in parentheses, or you can do it even without a calculator. -4 squared is 16, and then this -2 squared is 4, and radical 3 squared will be just 3, so 4 times 3 is 12. Guys, you can always use a calculator for that, but it's not too complicated. And if you add this, you're going to get 28. And then to take the radical of 28, guys, to take the radical of 28, I'm going to break it down as 4 times 7. And then radical 4 is 2, and radical 7, I got to leave it like that. So that is the simplified form. Guys, we want to leave it in a radical form. We don't want to leave it in a decimal form. So one has to know how to simplify radical 28 as 2 radical 7. So we have r, we have the x and y. Let us go ahead and write the 6 trig ratios. Guys, I'm going to start with the sine. Sine of theta we know is y over r. And what is my y? Is -4. So I have to write -4 divided by r, which is 2 radical 7. But guys, keep in mind we don't like to have radicals in the denominator, so we got to multiply, or we got to rationalize, so we got to multiply by radical 7 upstairs and downstairs. When we do that, what do I get? -4 radical 7, and then downstairs I have 2 times radical 7 times radical 7 is 7. Guys, we can still simplify. This -4 can be divided by 2, so you will get -2. We'll get -2 radical 7, and then we have a 7 downstairs, and this should be the simplified form for the sine of theta. Okay. Similarly, we are going to figure out the let us go ahead and figure out the reciprocal of sine, which is the cosecant theta. We know it's r over y, or you can just reciprocate. So we can reciprocate right here. So it's going to be 2 radical 7 over, keep in mind there's a negative, divided by 4, and we can simplify. We must simplify further. So it's going to be negative radical 7. And this 2 and 4 simplifies to just 2 in the denominator. Guys, you can also reciprocate this, but then you have to again rationalize and all that. So it is better to reciprocate the original ratio right here. Of course, you got to simplify 2 and 4, but that's not such a big deal. Okay. So sine cosecant is done. Let us move on to the cosine. The cosine of theta is x over r. What is x? X is -2 radical 3. And then here I have 2 radical 7. So the good thing is that 2's will cross out, so it is just negative radical 3 over radical 7, but we still have to rationalize the denominator, not the numerator. Guys, radicals in the numerator are totally fine. It's the radicals in the denominator that we don't like, so we got to multiply upstairs and downstairs by, again, radical 7, and when we do that, we get negative radicals. 7 times 3 is 21, and there's a 7 in the denominators. Guys, be careful with that calculation. Then the next one is the secant. Secant is the reciprocal of this, so we are going to just reciprocate this guy right here. So it's negative radical 7 over radical 3. You got to do the rationalizing here. Again, rationalizing here would mean multiplying by radical 3 now, right? Whatever is in the denominator basically. So it is negative radical 7 times 3 is 21, and downstairs you will have a 3. And we would get the same thing if we reciprocate this, and then we had to kind of still do the rationalize the denominator. Okay, guys, this is number 4. Then let us go to number 5. Number 5 is the tangent. Tangent is y over x. What is my y? Y is negative 4 over negative 4 is my y, and x is negative 2 radical 3. Negative 2 radical 3. Again, we can simplify first and then rationalize. It's up to you. So guys, negatives will cross out. It's going to be 2 over radical 3, and then I have to multiply upstairs and downstairs by radical 3. I get 2 radical 3 over 3. That is my tangent. Guys, once I have my tangent, I can quickly write my cotangent. I think I will have enough room to write my cotangent. So we can take this guy, or we have simplified this as 2 over radical 3. So the reciprocal would be radical 3 over 2. So guys, these are the 6 trig ratios. So there was slightly more work here because we had a radical and it was in the third quadrant. Guys, the other thing that we can quickly verify here, that we already know that only tangent and cotangent are positive in the third quadrant, and it just verifies here that sine and its reciprocal, cosine and its reciprocal are all negatives. Only the tangent and cotangent are positives. Okay, so guys, this is still example 1 part B. Now in my next video I'm going to show you a slightly different type of example, but we're essentially going to use the same definition, that sine is y over r, cosine is x over r, and tangent is y over x. And guys, this definition is not really new for us. We already know what is sine, cosine and tangent based in a right triangle, so it is just extension of that. Okay guys, keep practicing. I will see you next time. Till then, take care.